Dear student, welcome to my YouTube channel. Today I am going to start new topic, that is reducible to exact differential equation. In previous video I have explained about the exact differential equation, condition of exactness and solution of exact differential equation. Now in this topic, when the differential equation is not exact and we want to convert non-exact differential equation to exact differential equation, we need to multiply some suitable factor so that non-exact differential equation becomes exact differential equation. That suitable factor we can say as an integrating factor. So let's start the definition of integrating factor. If differential equation is not exact differential equation, sometimes it is possible to reduce into exact differential equation by multiplying some factor. So let's call that factor will be mu. It is known as integrating factor. Now how to find out the integrating factor from the non-exact differential equation? So there are four rules to find out the integrating factor. So let's start the first rule. If differential equation is homogeneous differential equation, then their integrating factor will be, so integrating factor we are writing IF. IF means it is integrating factor is equal to 1 upon mx plus ny, where this mx plus ny is not equal to 0. Now what is this homogeneous differential equation? If the degree of each terms in the differential equation is same, then we say that it is homogeneous differential equation. In that case, the integrating factor will be 1 upon mx plus ny. This m into x plus n into y is there. There is a multiplication between m factor and x. Similarly, n factor and y. Now come to the second rule. If differential equation of the form f1 of x into y dx plus f2 of x into y x dy is equal to 0. Now what is the meaning of this? This means there is a one function f1 which is a product of x into y dx plus there is a second function f2 which is a product of x into y into x dy is equal to 0. Then the integrating factor is 1 upon m into x minus n into y. So this is the integrating factor when the differential equation of the form f1 of x into y dx plus f2 of x into y x dy equal to 0. The condition is mx minus ny is not equal to 0. Now come to the rule number 3. If the differential equation is of the form m dx plus n dy is equal to 0 and find out the del m by del y, del n by del x, take the subtraction of that. So you will get something del m by del y minus del n by del x and divide that part by n. After dividing the n, you will get a one function which is in terms of x. You will get a function in terms of x that's called as a f of x. Then their integrating factor will be e raised to integration of f of x dx. Now when we have del n by del x minus del m by del y and we are dividing this factor by m, then you will get the one function which is in terms of y. Let's call this as a f of y. Then integrating factor will be e raised to integration of f of y dy. Now see the difference between these two terms, because here del m by del y minus del n by del x upon n is there. Then we will get the function in terms of x. That time the integrating factor is e raised to integration of f of x dx. And when we have something like this, del n by del x minus del m by del y upon m is there, then you will get some function in terms of y. Then integrating factor will be e raised to integration of f of y dy. Now come to the next rule. Rule number 4 is, if the differential equation of the form x raised to alpha 1 into y raised to beta 1 in bracket m1 of y dx plus n1 of x dy plus x raised to alpha 2 into y raised to beta 2 in bracket m2y dx plus n2x dy equal to 0, then the integrating factor will be x raised to h y raised to k. Find h and k by using the del m by del y equal to del n by del x after multiplying integrating factor. So if this differential equation of this form, x raised to alpha 1 y raised to beta 1, alpha 1 beta 1 are the some constant term, even alpha 2 and beta 2 also some constant term, m1 n1 m2 n2 also a constant term. When we have of this form differential equation, then you have to consider the integrating factor is equal to x raised to h y raised to k. Find this h and k by using this condition of exactness, del m by del y equal to del n by del x after multiplying integrating factor. So these are the four rules to use for finding the integrating factor. Now how to find out the non-exact to exact differential equation? So there will be some working rule to solve reducible to exact differential equation. So this is very important. When we have non-exact differential equation and we want to convert that non-exact differential equation to exact differential equation, we have to follow following step. So first step is write the given differential equation in the form of mx m dx plus n dy equal to 0. Then m equal to, write down m equal to function n equal to some function. Step 2 is differentiate this m partially with respect to y, that is del m by del y. Differentiate this n partially with respect to x, then you will get del n by del x. Now third condition is check the condition of exactness. If del m by del y is equal to del n by del x, then the given differential equation is exact. Then directly find out the general solution. If del m by del y is not equal to del n by del x, then differential equation is not exact. When the exactness condition is not satisfied, then we say that it is not exact differential equation. Now check all the rules 1 2 3 4 and find out the integrating factor. You have to check whether the given function is differential equation is homogeneous or not. Then check for second rule, third rule and fourth rule. According you will get the integrating factor. Now what will the next step? After getting the integrating factor, you have to multiply that integrating factor to the given differential equation, again compare with m dash dx plus n dash dy equal to 0. So I have mentioned one more m dash because this is a one form of differential equation also. We have noted the m dash instead of m. So m dash of dx plus n dash of dy equal to 0. After multiplying of integrating factor, you will get a one function, one equation which is differential equation m dash of dx plus n dash of dy which is equal to 0. Then write down the m dash and n dash. Then see the exactness condition of by using m dash and n dash, you will get del m dash by del y equal to del n dash by del x. Now if this exact, then find out the general solution. So your general solution will be integration of m dash of dx, y will be the constant, plus integration of terms of n dash containing not containing x,